Hello, can you hear me? I hope you can hear me right now. You have to unmute yourself.
Yes, able to hear you.
Okay, so the first question that we gave as homework was this. P of x is a degree 7 polynomial which satisfies this condition. P of n is equal to 2 power n for n goes from 0 to 7. And we have to find out the value of P of 10. Right? So you have to think of what kind of a polynomial will satisfy this. So what are the conditions that we know? P of 0 is 1. P of
Yes,
1 is 2. P of 2 is 2 square and so on. Till P of
yes,
7 is 2 power 7.
yes.
So from this information, you have to try to guess an appropriate polynomial. So this is a question which will be easy for you if you have done a little bit of binomial theorem. Binomial theorem, and if you've heard of Pascal's triangle. Have you heard of these concepts, Pascal's triangle?
Yes, Pascal's triangle. Yes, heard about that. Actually, I'm thinking in that direction also, sir. Uh,
Mm-hmm.
but not able to really succeed solve this.
This is the situation in Pascal's triangle.
Yes,
So notice one thing, the sum of the elements of each row. What is the sum? This is 1, this is 2, this is 4, right? What is this? 8.
this is 5. Yes. Okay.
This is 10 plus 4, 14, 16. Can you see a pattern?
Yes.
If you take the next row, it will come out to be 32, the sum. See, the next row is this 1, 5, 10, 10, 5, 1, right? This is the Pascal's triangle row, right?
Yes.
The sum is 32. So basically, this tells us a property of binomial coefficients. You must have seen this property before. NC0 plus NC1 till NCn is equal to 2 power n.
Yes.
Any row you take, for example, 2C0 plus 2C1 plus 2C2 will be 2 power 2. Right?
Yes.
So here what do we have? We have P0, P1, P2 till P7 is 2 power 7. So because this property is true, we can say that if you have P of n was NC0 plus NC1 plus NCn, that will be equal to 2 power n, right?
So,
If you take your polynomial as this stuff, right? Then
yes.
automatically it will satisfy the Pascal's triangle result for n0 to 7, right?
Mm.
So this is a combinatorial coefficient. This is not in the correct polynomial form, but we know how to convert NCR into terms like n factorial by n minus r factorial and r factorial. So this becomes n into n minus 1, n minus 2 till n minus r plus 1 by r 1 into 2 into 3 till r, right?
Mm.
So what I'm saying is P of n is NC0 plus NC1 till NCn. Then only it will satisfy the result of being equal to 2 power n, right?
Yes.
And we can write each of this as this stuff. So what we will say
Mm.
is NC0 is 1, NC1 is n, NC2 would be n into n minus 1 by 1 into 2, right?
Yes.
And NC3 would be n into n minus 1, n minus 2 by 1 into 2 into 3, right?
Yes, sir.
And so on till NCN is going to be 1 again, right?
Yeah.
So now notice that P of n, now it looks like an algebraic expression, right?
Yes.
Now it will start looking like it is having powers of n, right? So what we will say here is the polynomial we can guess is up to 2 power 7, it should satisfy the result. So we need to do it till x. If you write it like this, P of x, we can write it as xc0 plus xc1 till
XC6.
xc7, right?
Yeah, yeah, yes,
Why
yes.
c7? Because you have to satisfy P of 7 should be
P of
2 power
7.
7. But if you put x is equal to 8 in this polynomial, you will realize that P of 8 would be 8c0 plus 8c1 till 8c7, right? So it is not
Yes,
going
sir.
to be 2 power 8 because it's missing a last term, right?
Yes.
It is going to miss the last term, so it will not satisfy P of 8 is not 2 power 8, right?
Yes.
But any other term, lower term, for example, if I took P of 5, right here,
That is going to be
because you will have 5c0 plus 5c1 till 5c5, and after that it will be 5c6 and 5c7, right?
yes.
But these two terms are by definition 0. So it will be just 2 power 5 then. Correct? So basically, by understanding Pascal's triangle and knowing the binomial property, we have come up with this guess of our polynomial, right? And this satisfies the conditions of the problem that P of 1, P of 2, all of it is equal to 2 power 1, 2 power 2, and so on, right?
Yes.
So now our question is very easy. We just have to find P of 10. So we have to evaluate 10C0 plus 10C1 till 10C7, right? So in order to evaluate this, you can say that this is P of 10 will be equal to 2 power 10 minus 10C8 minus 10C9 minus 10C10, right?
Yes.
And these three terms you can easily calculate. 10C8 is same as 10C2, which is 45. 10C9 is going to be 10, and this is going to be 1. So 45 plus 10, 55 plus 1, 56. So you have P of 10 is 2 power 10 minus 56. So that is 1024 minus 56. So that is 968. That
Actually,
becomes your.
sir, actually, sir, I'm thinking in this direction while attempting. Although I have not succeeded, because I was trying in this way that I know that up to P7 I'm getting, so it would be 2 to the power 7, but plus something. But here, as you actually turn into that, we have to minus these missing terms. So that I'm not able to actually catch at that
No,
point of time.
I mean, we know till P power 7 the values, right?
Yes.
If you have P power 10, no, the main thing is to guess the polynomial. If you are able to guess something like this, then it's over. You don't have to subtract anything. Like the main difficulty is guessing, because P0 is 1, P1 is 2, P2 is 4. The reason we have guessed that particular polynomial is because I know Pascal's triangle, the sum is coming out to be like this, right? The sum of each row in Pascal's triangle is a power of 2. So that gives us the hint that maybe if I take NC0 plus NC1 till NCN, I will get 2 power n, right?
Yes.
So if this was my polynomial in n, I need to ensure that it doesn't satisfy for n is equal to 8, it should not fit, right?
Yes.
If it doesn't have to fit for n is equal to 8, that means your series should end at 7, right?
Yes, sir.
So therefore, I took P of n as NC0 plus NC1 up to only 7. Because if you go ahead, then it will satisfy also for 8 then, right? I hope you are understanding.
Yes, sir. Basically, what I understood is that this is basically the application of whole and soul Pascal's triangle, actually. Yes, although it is polynomial, but the
Yeah,
basic
the
thinking.
polynomial is coming by expanding each coefficient. Any NCR can be written as n into n minus 1 till n minus r plus 1 by 1 into 2 into 3 till r. So NCR can be written like this. So if you expand all of these terms, it will become a regular polynomial, right?
Yes.
Okay. The next question was the recursion question, where we had a sequence of polynomials with real coefficients which were defined by these rules. P0x was equal to x square plus 1 times x square plus 2, so on till x square plus 1009. And P of k plus 1 x was defined as P of k, pk of x plus 1 minus pk of x for k greater than equal to 0. We have to find the least number n for which Pn of 1 is equal to Pn of 2 is equal to Pn of 5000, right? So, okay, we have to find n for which this is satisfied. Some stuff is given, P0x is given, and there is a relation between pk plus 1 and pk, right? So let's think about that relation a little bit. And before that, let's look at the degree of this P0 polynomial. You should see that there are 1009 brackets, right? So what is the degree of P0x?
It's 1009.
No. How will it be 1009? You will multiply x square so many times.
2018.
It will be 2018, no?
2018, yeah. 2018.
Multiply, then it will power will become 2018, right? Maximum.
Yes, yes.
So degree of P0x is 2018. Can we figure out the degree of pk of x? Let's think about that. Fine. So let's put k as 1, for example, k as 0, for example. You get p1 of x is equal to p0 of x plus 1 minus p0 of x, right?
Yes, sir.
This is the first result. So it's the difference between two polynomials which have degree 2018, right? Correct, no? Are you understanding what I'm saying? These are 2018 degree polynomials.
Yes, sir.
The difference of these two, think about the highest term, highest power term. Here the highest power term in P0x is x power 2018, right? So here it would be x plus 1 power 2018. And here also it will be x plus x power 2018, right? What I want you to tell me is what is the degree of P1x? Think about it. What will happen?
I guess it will be same, no, sir? Because 018 degree with the P0, this minus
Think
that.
about it. See, the highest term here is x power 2018, right? After that, there are some other terms, right? What will happen when you do P0 x plus 1? It will be x plus 1 power 2018 plus other terms, right? Minus P0x will be x power 2018 and other terms, right? You should see that x power 2018 gets cancelled. Do you understand that the highest power term will get cancelled when you subtract?
Yes.
Is everyone understanding what I'm saying? Basically, the degree will come out to be 2017, no then? Because the next highest term here is x power 2017. And there the coefficients will not be the same. X power 2017 term, the coefficients will not be the same. Because
Mm.
you will have to leave some factors and all,
Mhm.
no?
Yes, sir. Yes, sir.
The coefficient here for 2017 term will be 2018 x power 2017, right? Correct. And P0x doesn't even have that. P0x next term will be 2016, right? Think about what I'm saying. In the expansion of P0x, what is the highest term? That is this one, right? What is the second highest term here?
Second highest is 2017.
It will not be 2017. How can you get 2017? All the powers are squares. How can you get 2017?
That is 2016.
Do you understand, or are you just saying 2016?
No, I've just subtracted that square. This is the next. By that way.
Do you understand why the next term is having power 2016, not 2017?
Yes, sir. Because it is coming as a square. No? Square.
Right,
So
so
the
you will never have odd powers, no? It will
yes.
always be 2018, 2016, 2014, and so on, right?
Mm. Mm.
So when you do P0x subtraction, you will have only 2016 next term, right?
Mm.
But when you do the expansion of this P0x plus 1, it will be x plus 1 power 2018, right?
Mm.
Plus x plus 1 power 2016, right?
Yes.
Do you realize that when you expand this, you will get a 2018 degree term, but you'll also get a 2017 degree term.
Mm.
I hope it is clear how 2017 comes out.
Yes, sir.
But it is not being subtracted, right? There is no term like that in the second one.
Mm.
So what I am concluding is that when you subtract the two polynomials, the resulting will be a degree 2017 polynomial. Are you
Yeah.
understanding what I'm saying?
Yes, sir.
So this pattern is going to be followed. For example, you can now think about P2x also. It will be P1x plus 1 minus P1x, right? When you think about it, you will realize that this will have degree 2016. When we had a P1x, we had degree this. When we had a P0x, we had degree 2018, right? There is a nice pattern that any degree of pkx will be 2018 minus k. We have already seen degree of P0x was 2018, and we already saw P1x was 2017. You have to convince yourself that even if you do P2x, which will be P1 of x plus 1 minus P1x, it will have degree 2016. You can show that easily. You have to try and do it yourself. Okay. I hope everyone is understanding so far what I'm saying.
So.
Yes, no, what?
Oh, yes, yes.
Okay. Now, given the question, what we have to figure out is least number n for which Pn of 1 and Pn of 2 and so on, Pn of 5000 are all equal, right?
Hmm.
Okay, great. So I need a Pnx. So if I define a new polynomial Gn of x, right? That is equal to Pn of x minus Pn of 1. Let's define a new polynomial. By the way, I already know Pn of x has degree 2018 minus n. This is what I wanted you to understand from what we discussed before, right?
Yes.
Based on the recursive sequence or results that are given, you can conclude that P1x has degree 2017, P2x has degree 2016, and so on. And Pnx will have degree this, right?
Yes, sir.
Great. So now you can see that the degree of this polynomial is less than 2018, but the polynomial's values are equal to each other how many times? 5000. 5000 different values are equal, right?
Yes.
So actually, if you call a new polynomial as Pnx minus this common value, let's call this value L. So this new polynomial is basically Pnx minus L, right? This is a polynomial of degree 2018 minus n, right?
Yes.
And actually, this polynomial is equal to 0 for 5000 values, no? 1, 2 till 5000. Gn of 1 is equal to Gn of 2 is equal to Gn of 5000, and all of them are equal to 0, right? Do you understand what I'm saying?
Sir, is it like it should be a constant polynomial, so n is equal to 2018?
Yes, it's a identical. This polynomial has more roots than its degree, right? So the polynomial is identically 0. The polynomial must be an identity. So the only way that can happen is basically you have P on n has to be 2018 then, right? If n is 2018, then the degree of the polynomial will be 0, right? This polynomial has more roots than its degree, so it's identically equal to 0, right? The only way that can happen is if the degree of the polynomial is also 0, right? So n must be 2018. Otherwise, it won't work. Because then the polynomial will not be degree 0 polynomial. This is the same logic that we did in the previous class in a question, where we said that if the number of roots is bigger than the degree, then the polynomial is identically 0. So here, for the Gn polynomial, its degree was 2018 minus n, and the number of roots is 5000. So therefore, Gn polynomial must be identically 0, so its degree must be 0, so n is 2018. I hope it is clear.
Yes, sir.
Okay. The next problem is this one. Find the remainder. Basically, what is the remainder when f of x is equal to 7x power 32 plus 5x power 22 plus 3x power 12 plus x square is divided by x square plus 1. find the remainder when this is divided by x squared plus 1. Obviously, you don't have to actually divide it to get the answer. You can try actually dividing it, but that is not required actually. So everyone must be aware of remainder and factor theorem, right? What is the remainder when f of x is divided by x minus a? Can you tell me?
A constant.
What is the value of that constant?
F of A.
F of a. The reason is if you divide f of x by x minus a, you will get something like this: x minus a and some quotient plus some remainder r of x, right? Correct? But now if you put x is equal to a in this equation, what you get is f of a is equal to 0 plus r of a. And actually r of x is not a function, r of x is a constant because the quotient was degree 1, so this is a constant, right? The remainder polynomial has to have lesser degree than the quotient. And quotient was already degree 1, so this is a constant number, right? Is everyone understanding how we are getting r is equal to f of a? Kaustav, are you understanding what I'm saying?
Yeah, yes, sir. Yes.
So what we will do is we'll try to use this result, but I need a factor like x minus a to do that. Here the factor is x square is there. So that is a little annoying. What we can do is change the function itself because all the powers are even. So I can take x square as my y and write the function as f of y. F of y is 7 y power 16 plus 5 y power 11 plus 3 y power 6 plus y, right? And it has to be divided by what? Divided by y plus 1, right? This is the same problem, but I've converted it into an easier situation. Instead of having a quadratic factor, I have a linear factor now. Correct?
Yes. Yes.
So remainder will come when you put y minus minus 1. This minus 1, if I put in f of y, f of minus 1 should be the remainder, right? It will be 7 minus 5 plus 3 minus 1. So that is 10 minus 6, 4. Your answer here is 4, and we have done it without division. You don't have to actually divide it. We are using remainder and factor theorem, this statement, that when f of x is divided by a factor like x minus a, the remainder is f of a. I hope it is clear. This is pretty easy. Right? Is it okay, this question?
Yes.
Okay, let's go to the next one then. We have a function g has the property that g of n is equal to 3n plus 5 for each of the 15 integers in the range 1 to 15. Which statement is true? So the statements are: if g is a linear polynomial, then g of x is 3x plus 5. Statement 2 is g cannot be a polynomial of degree 10 of degree 10. Third statement is g cannot be a polynomial of degree 20 and fourth statement is if g is differentiable, then g must be a polynomial. Okay, the function g has this property. And this property is satisfied for all the integers from 1 to 15. So g of 1 is 8. G of 2 is 3 into 2 plus 5, so 11. G of 3 is 14. And so on. G of 15 is 45 plus 5, 50. These 15 values are given for the function, right? So now you have to think about each option and carefully you have to understand. If g is a linear polynomial, then g of x is 3x plus 5. That statement should be obvious whether it is true or false. Can you tell me whether it is true or false?
Yes, if G is a linear polynomial, then Gx is equal to Cx plus 5, it is true actually.
Right, because in a linear polynomial, it's a graph of a straight line. You need only 2 points. Here there are 15 points given. Obviously, it will be that straight line only, no, this one. Correct, right?
Yes.
So this is correct option. Now you have to think of the others. Second option. Can G be a polynomial of degree 10?
Actually, it is linear, no? Gn is equal to 3 plus 5. So,
No, it is
I
not
think it is-
linear. See, G was not given as a polynomial. It was given as a function. No, it could be anything. The only thing you know is 15 values of the function. You don't know the nature of the function. Do you understand what I'm saying? 15 values are looking like they are linear doesn't mean the whole function is linear, right?
But sir, actually, I think you have actually teach us that multiplying factor. No? So there it may be differentiable like that. So it may be hardly become the binomial. I mean, quadratic in that case. If it is different, actually, multiply of root is existing that polynomial. So in that case, I think sir, it won't be a polynomial of degree 10.
Why? Why is it not be polynomial of degree 10? What is the reason you are saying?
Sir,
Vinay,
as per the information, it can be till a polynomial of degree 32.
as per the information, it can be a polynomial of
degree 42, 32, greater than or degree 40.
Why greater than equal to? Why are you saying 32?
Yes, sir. We know the value for 15 integers, right, sir?
Yeah, we know 15 values. Correct. Then
So I am assuming that between two integers, the graph comes down and meets the x-axis and goes up, sir. So there are two routes will be there.
why are you assuming such things?
It can be possible, right?
The question is though not, it can be anything. You have to decide whether it can be a degree 10 polynomial or not.
Yes, sir. It can be as per that it can be a degree of 10 as well as 20.
No. Think again. It is the same concept that we have done before. If there is a polynomial of degree n, how many roots are possible for it?
In
How many values are given for our g?
15.
15 values are given. Can you make a 10 degree polynomial with 15 given values?
Yes.
No, not necessarily. Why? Because if you construct a function f of x is equal to basically g of x minus 3x plus 5. What is known about this now? F of 1 is 0. F of 2 is 0. And f of 15 is also 0, right? You see that this f has 15 roots. If f is a polynomial, f has to be degree 15 or more. Do you understand that f has to have degree 15 or more if it has 15 roots? So can G have a degree 10 here?
No, 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 no. Then C is correct.
If G has a degree 10, then this polynomial is identically 0. Then G will be a 0 polynomial, which doesn't make sense because the values are not 0. Vinay, are you understanding what I'm saying?
So not really.
Not really.
Yes, sir.
In a quadratic equation, I'm telling you there is a quadratic polynomial. Can I say that there f of 1 is 1 and f of 2 is 2 and f of 3 is 3, give you 3 values? Can you make a quadratic now from this?
Sir, yes, sir, as we have a linear equation of ABC three times, three linear equations.
It's not a linear equation. I'm saying f is a polynomial of 2 degree and 3 values are given.
Like we will have a equation and the coefficients. So from these values we can obtain three equations like that.
Find the values a, b, c. F is a polynomial of 2 degree, 3 values are given.
Yes.
Find ABC. Kaustav, you also find ABC. Do you understand the question right now?
Actually,
A0, B1, C minus 1.
Is that a polynomial of 2 degree?
No, sir.
Can you make a, are you able to form a quadratic which satisfies these three? You will not get any A, B, and C which will be able to get you a 2 degree polynomial.
yes, sir. Actually, I'm thinking that way. I'm not getting that. Sure.
Whatever you do, if I give you 3 specific values and the polynomial was only 2 degree, you will never be able to make that polynomial. This is an overdetermined situation. You need a 3 degree polynomial to make it.
So, but it's like if we have some three variables, we will be needing three equations to solve, right? So,
Are you able to make a polynomial quadratic or not? Just tell me this much. No?
we are never able to make only linear thing.
So why is it not happening quadratic? According to you, it should happen, no? Quadratic should be able to come, which will satisfy these three, right? The reason is, if you pay attention and listen to what I say, you will understand the reason. If you have a quadratic polynomial, f of x, it is given. And it is also given f of 1 is 1, f of 2 is 2, f of 3 is 3. Let's make another new polynomial called g of x, f of x minus x. What is the degree of g of x right now? What is the degree of g of x?
It will still be quadratic.
And what is happening to g of x at the 3 points 1, 2, and 3?
So, like those points are of y, f of x is equal to x, right? So,
What is the value of g of 1 right now, according to our definition of g of x?
0, 0, 0.
So how many roots are there for g?
3.
Can a degree 2 polynomial have 3 roots? Do you understand the contradiction?
Yes, sir. Like f of x, coefficient of the leading coefficient of f of x is 0, so it will be a linear function. And if we subtract x from it, we are getting a constant, which is g of x.
Again, you have not understood the main logic. The idea is, if you assume that f of x is a quadratic, the new function f of x minus x is also a quadratic, right?
Yes, sir.
How many roots are coming for our new function here?
3 roots.
Is it possible for a quadratic to have 3 roots?
No, sir.
So that means that f of x cannot be a quadratic. Our assumption that f of x is a quadratic is wrong. Do you understand?
Okay, sir.
In our problem right now, they had given g 15 values. Do you understand what was given? Let's say g was a 10 degree polynomial. according to option B, if you assume it's a 10-degree polynomial, what is the new function f of x, which is g of x minus 3x plus 5? Is it a 10-degree polynomial also?
Yes, sir.
And how many roots are coming for f?
Give 15 degree.
15 roots are possible for 10-degree polynomial? Is it possible or not possible?
No, sir. No, sir.
So obviously f of x cannot be having a 10-degree. It must have 15-degree at least for 15 roots. There is nothing else here. This is the same idea that if the number of roots is more than the degree, then the polynomial is identically 0. If somebody says I have given you 15 points and the polynomial they said was only 10 degree, then the polynomial is 0. But that doesn't fit the question because the values are given for 15 points. So obviously the polynomial cannot be 10 degree. It is a higher degree polynomial. I hope it is clear what is happening. Is it clear
Yes, sir.
for both of you what is happening?
Yes, yes.
Okay. Yes, sir.
Okay, fine. Then you have to solve part. Option B is correct. G cannot be a polynomial of degree 10. Option 3 is false because I can easily make a polynomial of degree 20. The values that were given were 3n plus 5. If and 15 values were given. I will show you a degree 20 polynomial that will satisfy this. As long
Yes.
as the degree is bigger than the number of values, I can make a polynomial. If the degree is smaller than the number of values, there is no polynomial possible. For example, I will show you a 20-degree polynomial that will fit this. G of x is equal to, I will put x minus 1, x minus 2, till x minus 15 as a product. This will give me 15 degrees. I will multiply with x power 5, which will make it 20 degrees. And I will add a plus 3x plus 5. This polynomial, if you put g of 1, what is coming? Because of this will be
not
vanishing, right? So g of 1 will be the 8 that you need,
8.
right? Basically, all the values will be satisfied because of this, right?
Yes.
Whenever you put 15, from 1 to 15, everything, this part will get 0. And this part will give me the correct answer. Do you understand what I'm saying right now?
Yes, sir.
This polynomial has degree 20 and it satisfies all the 15 points. And I am able to construct it because I made sure that this part was degree 20 and it vanishes at all of these points, but it will not vanish if I put any other value. If I put g of 17, this part will not vanish. Right? I hope it is clear more or less what is happening. Vinay, is it clear what happened in this question?
Yes, sir.
Okay, fine. One final problem that you need to try yourself as homework. This problem is
Sir, option
26.
B is correct, no?
Option B is correct. Option C is
Op-
false.
Option B, sir. D is correct, no?
Yes, there cannot be a polynomial of degree 10.
No, sir.
Op-
D, you also mentioned, no? If G is differentiable, then G must be a polynomial. That is correct, no? That option?
No, you have to think about it. That is false. If G is differentiable, then G must be a polynomial. We don't know anything about. You have to think of a counter example. For example, let's say G of X. We have made a 20-degree polynomial just now, right? Which fit
Yes, yes.
our situation, right?
But if it is actually quadratic, then it must be differentiable. But again, that is not the polynomial.
1 second. Suppose this is the situation. This was my 20-degree polynomial, right?
Hmm.
20-degree polynomial where hx was, I had taken hx as x power 5, right?
Yes.
This was a polynomial and this is differentiable at all of these points. But if you take h of x, for example, is this differentiable? H of this function, is it differentiable or not? We can check it. It will be a polynomial, so it is differentiable. Okay. But if I put h of x as sine x, G could be sine x also. It will still satisfy all the values, right? Where I'm saying G of x is basically sine x times x minus 1, x minus 2, till x minus 15, plus 3x plus 5. So 3x plus 5 ensures that all the values are fitting, right?
Yes.
But now, this function is differentiable clearly because sin x doesn't make it non-differentiable. Sin x is completely differentiable, right? Do you understand that this is a 15-degree polynomial multiplied by sin x? So, do you understand that this is still differentiable?
Yes.
The whole function is still differentiable because sin x is continuous and differentiable, right?
Hmm.
But do you think this is a polynomial? If you put sin x inside, it doesn't become a polynomial now, no? This is a counter example where the function is still satisfying all the values. The function is differentiable, but it is not a polynomial anymore. If I had put x power 5, it is a polynomial. But if I put sin x, it is not going to be a polynomial anymore. I hope you understand what I'm saying.
Yes.
Even though it is still differentiable. Correct? Okay. So option D is false. The correct options are 1 and 2. Now, this is the question which is homework. Find a single polynomial P of x that satisfies the following properties. First property is if P of x is divided by x power 100, the remainder is a constant polynomial 1. Basically, the constant number 1 or remainder is a constant polynomial 1. 1 is also a polynomial, by the way. F of x is equal to 1 is a polynomial. It's just a constant polynomial. And the second property is if P of x is divided by x minus 2 whole cube, the remainder is the constant polynomial 2. So, an interesting question. You have to find the polynomial which, when divided by x power 100, gives a constant polynomial 1. And when divided by x minus 2 power cube, the remainder gives a constant polynomial 2. So think about it. That we'll discuss in Friday's class. And then we'll start a new chapter from Friday onwards. We'll basically look at a little bit of number theory from Friday onwards. So
Sir, our class will be Friday, Monday, and Tuesday, or Saturday, Monday, or Tuesday?
it is Saturday. I made a mistake.
Sir.
It will be Saturday. So we'll do it on Saturday. Okay, that's all for now. I'll see you next time.
Yeah.